All right, so if we have a tick axis like this, and I'm going to go ahead, I'm going to draw some arbitrary line. I'm just going to go through this bad boy, something like that, okay? Now, we define some arbitrary point somewhere over here, okay? And now we want to know, okay, how can I reflect this point along this line? So it ends up somewhere probably over there. I'm very much just eyeballing this, right? But then that point will be reflected to that big green blob will be reflected to the other big green blob. How we can do this is, first and foremost, is by drawing this line that actually connects those points, right? Because if we know the equation of that line, we could work out or any of the coordinates, any of the points along that line. I'm talking about this line over here that goes from the, oh, interesting. Okay, let's see if that, oh, beautiful. Okay, cool. Talking about that line. And this line is actually going to be perpendicular to this line, right? So we're going to make it perpendicular in the sense of we're going to say, okay, whatever this gradient is of this line, which we've found, right? This one that I'm drawing over in green, we know that the perpendicular gradient is going to be -1 over m, right? So if this gradient is m, this gradient is -1 over m, okay? So we know what that gradient is going to be for this line. So now we're going to have y is equal to -1 over m, and then we're going to need some sort of c. Let's call this like a different c. Let's call it like c2, because this will be this one will be c1 for that line. And how we can find it is just by plugging in this point. We'll have this point over here, which we've defined, and so we can plug that point into this equation, and we can work out what c2 is. With that, when we now have the equation of that line, we could, I'm trying to think what's the best way to go about it. The next step is actually to find what this point is, this point of intersection. Okay, so over here, once we have that point of intersection, we could do a couple things. We can look at the different ones. Let's for now just draw this perpendicular line, and then let's come back and we'll look at how do we find this bad boy. Okay, so to draw the perpendicular line, let's go ahead and make our new gradient. So I'm going to say like m perp for m perpendicular. And that's, we know it's going to be equal to -1 over m. Okay, and now we want to figure out what our c is, right? Let's c perp for this new one. And so we already have, like y is equal to mx plus c. And like we said before, then c is equal to y minus mx. Y, we can just substitute in this point over here for our y. We can substitute in this point for x, and our m is -1 over m. So our c perp is simply going to be p3y minus m perp times by p3x. Okay, and now we have this other equation of the line. Let's go ahead and check it out. So very similarly, I'm going to go ahead. We already have x min and x max. So let's just find our new y min. So y min perpendicular, y min perp. That's going to be equal to m, our new m, so m perp, times by x min plus by c perp. Now the equation, right? We're saying, what we're essentially saying is we're saying y is equal to m perp times by x plus by c perp. Okay, that's the equation. And then we're going to say let y max perp is equal to m perp times by x max plus by c perp. And then we can draw a line. So now I'm going to make sure I get it right. x1, y1. So our x1 is going to be x min. And then this is going to be y min perp. And then x max, y max perp. Okay, draw a line between those 2 points. Now, hopefully, we get a beautiful perpendicular line. Look at that. Okay, so now we can see that that line is always perpendicular as we move it around. It's always forming that nice 90-degree angle. Okay, now the question is, let's find this point of intersection over here. Right? What is the coordinate of the point where this intersects, where the perpendicular line intersects with this line. And we're going to go ahead, jump back into our whiteboard, and see if we can't come up with a... Okay, so to find this bad boy over here, we're going to need to do some good old-fashioned equations and algebra. And we can just find a generic form of how do you find the coordinate of intersection for any two lines, right? If I say y1 is equal to m1 x1 plus c, let's say that's one equation. And then I have another one, y2 is equal to m2 x2 plus c. Okay, so those are two equations of a line. Let's imagine this one, this line over here was what was this first one, right? This one was this y1 line. And then this one was our y2 line. So at this particular point over here, our y's and x's are equal, right? The y1 and x1 for this line is the exact same as the y2 and x2 for this line. So we can go ahead and just make them equal. So we get the following. So I'm going to say m1x. Let's keep it in black over here. Otherwise, we're going to be vomiting rainbows with so many colors. m1x1 plus c. Let's actually take away the x1 because it's unnecessary now because we're dealing with the same x point. So m1 x1 plus, this should actually be c1 and that should be c2 because they'll have different y-intercepts. So m1 x plus c1 is equal to m2 x plus c2. And now let's go ahead and solve for x. So let's bring all of the x's onto the left side. So I can say m1x minus m2x is equal to c2 minus c1. I'm going to factor out the x. So I'm going to get x m1 minus m2 is equal to c2 minus c1. And then I can just divide both sides by m1 minus m2. So I get x is equal to c2 minus c1 over m1 minus m2. Now this is a generic equation for any two straight lines. Any two straight lines this will work. We could simplify this a little bit more because this one, this m2 or the m1 is actually equal to -1 over m1. But it's unnecessary for now. This is good enough. You can go ahead and, if you're wanting to, take it a step further. And then the y, right, if we're then wanting a y, we know our equation is y is equal to mx plus c. So we could just take whatever that result is and put it into that bad boy, and we're going to get this bad boy. So let's put that into code. What this looks like in code is the following. I'm going to go ahead and make that. So I'm going to call let x intersection, x int, for x intersection. And then I'm going to follow the formula we just created, which is c2 minus c1 over m1 minus m2. So we're going to say c perp minus the other c, which is just c, I believe. Yeah, it's just c. And we're going to put that over m1 minus m2. So the other one, right? So the m that belongs to this c, which is just m. So then we're going to say m minus m perp. So that will give us our x intersect. Then if we want to find our y, it's as simple as saying that y is equal to our m perpendicular times, actually you could use either one now, right? Because this x-intercept is the same for both, right? And you could make sure you could test that. So let's actually just use the first one. So we can say m times by x int plus by c. That will be the point. And let's go ahead and make sure. Let's put a circle. Let's go ahead. We're going to make it gold, stroke gold, because this is the golden point that we'll be able to find. And it's going to be x int y. Oh, we can't say y. Let's say y int because we already defined y before. So y int. And let's make it a bit smaller. Let's go 10. Now we should see a nice intersection over here. Look at that bad boy, okay? Cool. And now you can see as I move this line, we're always keeping to that point. Okay. So we found the perpendicular line and we found where it intersects with the original line. How now do we take us a step further and reflect this point along this line? Let's go ahead and just change some colors. Let's make this new line, the perpendicular line, let's make it green. And let's make sure we keep with those circles. Let's see, what does that look like? Okay, cool. We have a lot of colors going on. But now you can see, so the red line is our original line and the green line is our perpendicular line. Let's see how we can take us a step further and find the reflected point. So to find the reflected point, there are actually two methods. We're going to go through both of them. The first one, you can maybe start to see it just from this picture over here, right? If I have this point over here, and now if I go a certain amount up and a certain amount to the left, right? That delta y over that delta x. That is going to be the exact same amount of how much I go up from this point over here and how much I then go left to that delta y, that delta x, because the gradients have to be the same, right? It's a straight line, so the gradient between any 2 points is always going to be consistent. So the gradient from p dash to p is going to be the same, right? You can see that from this diagram. That ratio to that ratio is always going to be the same because it's a straight line. So we could work out how much does our y change, how much does our x change, and just add it to that. That's one method. The other method is through midpoints. You know that this point over here is the midpoint between these 2 points. It's right in the middle of the two. And we know that the midpoint formula looks like this. We can say that xm for our, let's write this a little bit nicer. xm, which is our midpoint, our x midpoint, is equal to x1 plus x2 over 2. And our ym is equal to y1 plus y2 over 2. Okay, now I want to know what this point is. So I want to solve maybe for x2 here, right? Or for x1. I know what this point is. We've worked out what the intersection point is. We've declared this point from the beginning, this point. So we have that. So for x2, that's simply going to be, if I solve for x2, that is, so x2 is going to be equal to 2xm minus x1. And then the same will happen for y2. So y2 is equal to 2ym minus y1. So these are two completely different methods. Let's put it into code to try and reflect it. Okay. In code, it looks like the following. Let's go with the delta x, delta y method first. So I'm going to make a variable, delta x, right? And that's, delta x is the distance from our point of intersection, the change in x from our point of intersection to our, it went away now, because I haven't actually finished this. Let's see if I just put that. We should get our nice drawing back. The delta x is just the distance, the x distance from our intersection point to this point that we defined. So we can say that that is x int minus the point that we defined, which is this, p3x and p3y, minus p3x. And then we could say the same, let delta y is equal to y int minus p3y. Okay. And now, this is the beauty. What we'll be able to say is that this new point is simply going to follow this. It's just gonna follow that that same pattern. So if I say, let's do it like this. I could say let p, what should I name this? Reflected p, let's say p reflected, okay, reflected point or point reflected. Then that is going to be our x-intercept plus by delta x. And let, p reflected x. Okay, so let's do, naming things in programming is like the hardest thing. P dash, p new, oh my goodness. We're just going to call it P4. Okay, P4, P4X and P4Y. And then the P4Y is simply going to be our y-intercept plus delta y. And now if we draw that point, we will be able to see that. So I'm going to go P4X, comma P4Y, and we'll go 20. And would you look at that? There is that point. And now notice as I move this across, it's always remaining equidistant. So the distance from this point to this point. So from the point that we defined to our intersection point is equal to our intersection point to our reflected point of the point we defined, right? You can move that around. And now this works for any line, as you can see, right? So it's a very powerful tool in regards to being very flexible to anything we give it. Let's just go over the other way, right? Where we talked about the midpoint formula, where we said x2 is going to be equal to 2 times by xm, the midpoint, minus x1, right? xm is our x-intercept, and x1 is the defined point. So let's just do it for p4x and see if it works. So I can say 2 times by xint minus p3x, which is the x coordinate of that. And let's see, do we still get it? We do. There you go, right? Beautiful. Yeah, so that's how you can reflect a line using code, using math, using all this kind of fun stuff. We might do another video to show how you could do this kind of with a different approach using rotations, translations, and scales, which is a little bit more like linear algebra. Linear algebra is another fancy math thing that we'll get into. But we will end this project here. I hope you've enjoyed it, and I'll see you around for the next one.